Okay, so to solve problems like 4, 5, 6, and 7, that it's not as clear cut, when is it going to be positive, when it's going to be negative, when is it going to equal to 0, this is the method that we will use. These are the steps you'll use. One, you'll find where the numerator equals to 0. Number 2, you will find where the denominator equals to 0. 3, you'll set up a number line and indicate where it is defined or undefined, defined or undefined. Number 4, you will choose test values. And number 5, you will and plug in. Then number 5, you will answer the question. All right, so these are the steps we're going to follow. I'm not going to write these down every time, but I will talk you through them. So it goes like this. For the first one we're given, number 4 is 7 minus 3x divided by 1 plus x is less than 0. Okay, we want to see, where does the numerator equal to 0? Where does the denominator equal to 0? So we solve for x, and we get 7/3 is where the numerator equals to 0. I'm going to put a solid circle right there because it's okay for a numerator to equal 0. It can be defined. I solve for this one. I get x is -1. I'm going to put an open circle to remind myself it cannot equal to 0. So now I set up my number line. Whoops, I set up my number line. And on my number line, I'm going to mark -1 right here, -1 right here. And I'm going to put a big open circle to remind myself it cannot ever equal that. And then 7/3 is what? That's 2 1/3. It's somewhere over here. This is 7/3. I'm going to put a closed circle to indicate that that is, it can be there. It's defined. Okay. Then I'm going to choose test values. That means, do you see how my number line is split up into 1, 2, 3 different regions? I'm going to select a test value in this region, something less than -1, maybe like -2. I'm going to pick a test value between -1 and 7/3, maybe 0. I'm going to pick a test value greater than 2 1/3, maybe something like 3. Then I plug the test values into the function r of x. This is r of x. So if I put in -2 here for this x, 7 minus 3 times 2, times -2, would be 7 plus 6. So I would get a positive in the numerator. Okay. If I put in -2 right here, 1 plus -2 gives me a negative. I have a positive divided by a negative, which means this region is negative. I mark out my test value because I have a bad habit of using it when I'm not supposed to. That's all I needed it for. I'm going to plug in 0. 1 plus 0 in the denominator is 1, which is a positive in the denominator. I'm going to plug in 0 for x. 7 minus 0 is 7, which is positive. A positive over a positive is a positive. So r of x up here is, this tells me the sign, whether it's positive or negative. 3. If I plug in 3 for x, this is going to be a positive down here. If I plug in 3 for x, this is 7 minus 9, which gives me a negative up here. This is a negative. So then I interpret my chart and answer the question. When is r of x less than 0? Over here and over here. It didn't say or equal to, so I don't include that. So the solution here is going to be from -infinity to -1, and then from 7/3, don't include 7/3 because there was no or equal to infinity. So that's how you would answer that one. Let's look at number 5. The steps are similar. R of x is equal to x plus 3 squared over x minus 4. And we want to know when it's greater than or equal to 0. You set the numerator equal to 0 and solve. You could take the square root of both sides and get x plus 3 is equal to plus or minus the square root of 0, which is just 0. It doesn't hold a sign. And then you would say, well, this is when x is negative 3. This could be defined there. X minus 4 will equal 0 when x is 4. This cannot be defined there. You set up your number line. You'll say, here's negative 3. It is okay to equal negative 3. Here is 4. It is not okay to equal 4, so I indicate that with the open circle. I choose some test values, maybe negative 4, 0, and 5. I'm going to plug these into the function itself. If I put negative 4 in here, it's getting squared. That's going to be a positive in the numerator. Negative 4 minus 4 is a negative. Positive over negative is a negative right there. If I put in 0, 0 plus 3 is 3. 3 squared is positive in the numerator. If I put in 0 in the denominator, 0 minus 4 is negative. I get a negative right there. 5 plus 3 is 8 squared is a positive in the numerator. 5 minus 4 is a positive in the denominator. I get a positive right there. Then I'm like, well, what am I supposed to answer? I'm supposed to answer when is this positive or equal to 0? Well, it's positive over here and it's equal to 0 here. So I have to include both of those. So my solution here will be at the point, when x is negative 3, and there's only a single value. So I indicate in little set notation at negative 3 it equals 0, and then it's positive to the right of 4, from 4 to infinity. So that's how I'll answer that one. Number 6, we have r of x is equal to 3x plus 5 all over x squared minus 9, and this is less than or equal to 0. We set the numerator equal to 0 and solve, and we're going to get x is negative 5/3. We set the denominator equal to 0 and solve. I chose to factor this difference of squares, and so I get when x is negative 3 or when x is 3. So we get these values. Now this came from the denominator. These are open circles. This came from the numerator. This is a closed circle. So I want to indicate that on my number line. Here is negative 3. Here is negative 5/3. Here is positive 3. Now these have to be open. This can be closed. I will select some test values. And so maybe I'll pick something like negative 4. Let me see. What is a nice value between, this is negative, let's see, negative 1 and 2/3. So a negative 2 would be nice. Something between a negative and a positive. I'm going to select 0 and then maybe 4. These are my test values. And I'm going to plug this into the function itself. So if I put negative 4 into 3 times 4, that's negative 12 plus 5. That's a negative in the numerator. Negative 4 squared is 16 minus 9. That's a positive. A negative over a positive is a negative. All right. Negative 2. 3 times negative 2 is negative 6 plus 5. That's a negative in the numerator. Negative 2 squared is 4 minus 9 is another negative. That is a negative over a negative, which gives me a positive. If I put in 0, I get 5 in the numerator, which is positive. If I put in 0 for the denominator, I get a negative 9. Positive over negative is negative. 4 times 3 is 12 plus 5 is positive in the numerator. 4 squared is 16 minus 9 is a positive. I get a positive. So these are my indications of what my function is doing. All right, when it's positive, negative, or equal to 0. How do I answer this? Where is this function negative or equal to 0? Well, it's negative here, it's negative in this region, and it's equal to 0 here. So I want to say from negative infinity all the way up to negative 3. And then I want to union that with, it's equal to 0 at negative 5/3. And then it's all the way to 3. Now I cannot include the 3 because it was not defined there, or negative 3 because it's not defined there. So that's going to be my solution to that guy. All right, the last one, number 7. We are supposed to solve. I only included this one because it came to us in just a little bit of a funky form, so I want to show you how to handle this. 13 over x minus 5 over x squared. When is this rational function, which looks a little bit different, greater than or equal to 0? So the first thing I'm going to do is make it look better, and so I'm going to get a common denominator for all of these. This is really a 6 over 1. If I get a common denominator of x squared for everybody, I had to multiply this denominator by x squared and this numerator by x squared. So this becomes a 6x squared. If I want an x squared down here, I have to multiply this one by x, this denominator by x, and this numerator by x. So minus 13x over x squared. This already had an x squared, so that is fine. Now this looks normal to me. Then I would go ahead and do my normal stuff. When is 6x squared minus 13x minus 5 equal to 0? I'm going to factor this because factoring is not that bad once you get used to it. If you can't factor or have a hard time, you can use quadratic formula here. But this will factor into 3x plus 1 times 2x minus 5. You can use the AC method to do this, or trial and error, or the box method if you have a better method, but this is a nice way to factor this. This tells you that this will equal 0 when x is negative 1/3 or when x is 5/2. When will the denominator be 0? When x is 0. This is undefined because it came from the denominator. These are defined. Set up your table. So you have negative 1/3. It's okay to equal that. You have 0. It is not okay to equal that. You have 5/2. It is okay to equal that. Then you will pick some test values. I'm going to pick negative 1. I'm going to pick negative 1/4. I'm going to pick 1, and I'm going to pick 3. I'm going to plug these values into r of x. Okay. If I put in, and I'm going to look at this when I do this, negative 1, I rewrote my numerator. If you look up here, I rewrote my numerator into 3x plus 1 times 2x minus 5. You do not have to do it this way, but I find this easiest to do it this way. Okay, let's look at the denominator first. Whatever we stick in there, we can't put 0 in there because that is undefined, but any other value we stick in there, that's going to be positive. So we know in each of these cases, the denominator is going to be positive. So we just kind of have to look at the numerator. If I put negative 1 in here, 3 times negative 1 is negative 3 plus 1. That's a negative. Negative 1 times 2 is a negative. 2 minus 5, that's another negative. A negative times a negative is a positive over a positive. This is a positive. Now, if you don't want to do it that way, you can just stick negative 1 into this expression, 6x squared minus 13x minus 5, and see what you get. Negative 1/4. 3 times negative 1/4 is negative 3/4 plus 1. That's a positive. Negative 1/4 times 2 is a negative half minus 5. This is a negative. I get a negative over a positive. That's negative. If I stick in 1, 3 times 1, this is a positive. If I stick in 1, 2 minus 5 is a negative. I have a negative over a positive, which is a negative. And then if I put in the 3, that's a positive. If I put in the 3, 6 minus 5 is a positive over a positive. So this is the chart I get. Let's interpret our sign chart. We want to know, finally, when is this positive or equal to 0? It's positive and equal to 0 here. It is positive or equal to 0 there. You don't include this part. So our solution here will be from negative infinity to negative 1/3, and we can include the negative 1/3, and then nothing in here, and then from 5/2 to infinity. And that's how we will answer that one.